Hey everybody, I've put together this quick video to review all things logarithm related. So those logarithm properties, how logarithms are formed from exponential expressions, and how we can take an exponential expression and turn it into a logarithm. We'll also take a quick moment and talk about what a logarithm graph looks like, but hopefully you remember that from the function family work you did earlier in the week. All right, so here are two examples. This first problem is a logarithm and we need to write it in exponential form. Notice how I start with my base, n to the negative 12th power is equal to m. So if you remember in class, I used to start at the base and I would make this e standing for exponential, base power equals a number, n to the negative 12 equals m. In the second example here, I have something exponential and I want to write it logarithmic. So I'm going to start up here and draw down, swing through my base, which is 18. The log base 18 of v up and over to form like a little g is equal to u. Base, this is going to be your number, or this is going to be your power. No, this is going to be your number, and then that gives you your power. So the log base 18 of v is equal to u. And then here's an equation. It's an equation because there's an equal sign. This is a nice equation because it's pretty equally balanced. I have the log base 6 of something is equal to the log base 6 of something. So right off the bat, I can either just drop the log away, or I can think about raising both sides to the sixth base 6 value, and then 6 to the log base 6 cancels out, and 10 minus 5x drops down. Same thing happens on the right-hand side of the equation. So the 6 to the log base 6, that cancels. All right, from here it's pretty straightforward. My 10s cancel out. I'm going to swing my smaller negative, or my bigger negative, my smaller number, over to the other side so that I'm dealing in something positive. I end up with 0 is equal to 3x. 0 divided by 3 is 0, so my final answer is 0. Remember, you always want to go back and check for extraneous solutions, or remember, extraneous means it's something that seems mathematically correct, but just doesn't work in the context of the problem. Remember that we can't take the log of a negative number. So if I were to plug in a 0 here, would I be taking the log of a negative expression? Nope. If I plug in 0 here, nope. This is still positive, so I can take the log base 6 of that. In our next example, number 4, here this isn't quite so nicely balanced. I have two log base 9s on the left and no log base 9 on the right. So I have three properties. Remember, subtraction becomes division when you're condensing. Addition becomes multiplication when you condense. And then you can like expand the log base m to a power. Power is going to drop down in front and get multiplied by the log of the number. So these are our three properties that we worked on a lot in Algebra 2 and in Pre-Calc. Over here, I can take these two log base 9s that are being subtracted, rewrite it as a quotient. So I have the log base 9 of 10 over negative 5x is equal to 2. Just like I did in number 3, to cancel out the log base 9s, I'm going to use a big 9. So big 9 on both sides. 9 to the log base 9 cancels. I'm left with just this expression. 9 squared becomes 81. I'm going to think about this kind of as a ratio now, or a proportion, I mean. 81 is a ratio, 81 over 1. So 10 over negative 5, I can reduce that down to like negative 2 over 1, cross multiply, and at the end of the day, I end up with x equals negative 2 over 81. So I kind of glossed over a lot of algebra here, but you can, pause the video if you want and copy this down so you have it when you do your homework, or think it through a little bit deeper. All right, last example, number 5. Here I have two log base 4s, log base 4s on one side, and then no log base 4 on the other side. I'm going to take the plus and turn it into multiplication. That's a property from a few slides ago if you want to go back and look. Rewind. Then big 4 on both sides. 4 to the log base 4 cancels, and I'm left with just negative 9x. 4 to the first power is 4. Solve it. X is equal to 4 over negative 9. I didn't check for extraneous solutions in my last example. I should check for extraneous solutions right now. So if I plug in 4 over negative 9, is this going to be a negative number? Nope. The two negatives will cancel, and I'm looking at like the log base 4 of 12 over 9, which is totally doable. And then over here, I'm not plugging anything in, so that's just a number. I mean, I could figure that out at my calculator right now if I wanted to. So that's the size of that. Remember that when you're graphing logs, Logs have walls, exponents have floors, exponential functions have floors. So when you're trying to match something up, don't worry about the base. The base is just going to kind of stretch or compress a graph. Think about your translation rules. And remember that logarithms like hit a wall as you move backward in time. All right, that's all I have to say about that. Good luck.